And recording.
Hi, everyone. I had the pleasure with working with Aarmin and Aris, and my name is Tyler. And for our ME 165 final project, we chose to make a mechanical toothpaste dispenser. So just a little bit behind how we generated an idea to make a toothpaste dispenser to begin with was we kind of thought about the whole motivation was getting a toothpaste dispenser that just perfected the whole kind of process of you're waking up in the morning and having the perfect amount of toothpaste being dispensed while also being able to dispense all like the little amounts of toothpaste that's left behind. And the purpose of this project was to showcase our learning about CAD within Fusion 360 after learning in certain derivations of the program's functions and then using different functions. We wanted to create a technical design for a toothpaste dispenser that was able to be fully functional.
Okay, so going into the working principles of the design, we wanted to have a good way for the user to kind of hold and clamp the toothpaste dispenser. So we came up with a two-handled system. So this is a two-handled system. It consists of two separate parts that we had CAD'd in Fusion 360. Majority of being a outer portion and an inner portion. The second primary working principle of this design system is this gearbox system that we created. It pretty much is two similar spur gears that we have that make a little bit of contact here, and this is where the toothpaste tube will be inserted. So here we have some videos showing a bit of animation for functionality. So first I'll show the part of the handles. So as you saw in the video, we decided to go with only allowing the handles to move as far as a 90-degree angle and then to close and stop at about a 30-degree angle. And this was just to have a good ease of use for inserting and clamping the tube. Going to the second part of the functionality, we have an animation here for the gearbox. I'll play it here. So with the gearbox, essentially what we're going to have is after the tube is inserted into the front portion here, the user would clamp it down using the handles. And then after, there is a little tab here that they can use to twist the tube. And as it twists, the tube will be extruded out and all the contents in it will have come out of the toothpaste tube. It's supposed to be crimped by the two gears in order to extract every single bit of toothpaste out of it.
And here's an exploded view of all the components that we used. As you can see, you could see little spur gears as well as the clamps, as well as the pins and some of the sockets as well. And here's a little animation just kind of showcasing what we just showed you with the exploded view. Um, yeah, and here's the video for it. And it shows you the trail of where it's supposed to be inserted, how each individual piece is going to be connected with one another.
So one of the key points of this project was we had to understand the software behind CADing. So one of the most important parts of any design in CAD is the projection types. So when you make an object in CAD, you can arrange the different projections or how to view the object. So there's parallel projection, and you could see the outline of different projection types in the photo. But parallel, and there's some under it like orthogonal and oblique. And isometric is usually the standard for viewing the image and sending it as a drawing. But you also use perspective, which is you click on the face of the object and you actually do sketches on there or do an offset plane to create a sketch. And isometric is just to see like the whole picture of the object, and orthogonal is more to create sketches. So for the different projection viewings, there's different matrices we learned that could that you apply for the all the points of the rigid object or solid. So how it's done is you first rotate the object to the desired face. So an example would be, say we want to get the top view. We first have to rotate the object by 90 degrees, and then we would set all the z coordinates to 0. This would give us the basic matrix for the transformation matrix for a top view. But there's different matrices for all of them. There's homogeneous transformation matrices for like just translating the object, scaling, mirroring, rotation. So a lot of these are used in the CAD software. So these are just some of the different views that we had for our object. As you can see, we have the left view in the left corner, we have the front view in the center, top view below it, and the isometric view. These are just to let the person have a better idea of our project. And this is just the technical drawing that we have. The top left corner is the front view again. The right is the left or the right view. And the bottom right is the isometric. But the bottom left corner one is a section view and it's scaled 1 to 1.5. And this shows the interior of the gears. And this is just to see the internal sections, such as the through hole for the pin to be slotted in.
And for our last bit of our presentation, another integral part about our learnings from 165 was shading. So here we have our rendered view of our component, and we chose, or we didn't choose, we know this is going to be specular reflection. Pretty much looking at it, basically the definition of specular reflection is that the reflected light radiates differently in different directions, and in extreme cases, it radiates only in one direction. And in this example specifically, you can clearly tell it's coming from one direction. It's radiating from the backside, and it kind of gives you a little bit of a depth perception as well as shaded in different areas because the light is only hitting from the backside of it and not only on all areas. That concludes our presentation. Thank you for listening.